Meeting is being recorded.
Hello, everybody. Good morning and good afternoon. Thank you so much for joining us today. My name is Rigo Villa. I'm one of the community managers on the Cisco Learning Network, and I'll be your host today. In this session, we will be covering MAC Authentication Bypass in ISE with our speaker and presenter, Thomas Howard. But before we get started, I wanted to share a couple of quick housekeeping notes. First, I do want to let our attendees know that if you run into any technical issues during the webinar, we're going to do our very best to resolve it as soon as possible. So we just want to thank you in advance for your patience and understanding. Next, if you have any questions during the session, we ask that you please post them in the question and answer panel as displayed on the screen here in front of you, as that would help our panelists manage to keep track of all of your questions and would also allow them to provide you with a much more timely response. Also, if you experience any audio streaming issues during the live presentation, I do recommend using the call-in telephone number that I'm going to be posting in the chat window here in just a moment. And at the end of this webinar, you're going to get a pop-up survey with a couple of questions about today's presentation. And we would really appreciate it if you can just take a moment to fill it out and share with us any thoughts or feedback that you may have about today's webinar. I also want to let our attendees know that this session will be recorded and will be available for on-demand viewing within approximately 5 business days after today. And I'll be sure to share some more information about that in the chat window a little bit later on. And last but not least, I want to let everyone know about our upcoming ISE webinars. So our next session is coming up next month with Cisco SD Access with ISE. That's going to be on Tuesday, August 1st. And then we're going to have our next session, which is going to be ISE Eternal Evaluation for your lab on August 3rd. That's going to be the Thursday. And I'm going to be sharing some information on how you can register for these upcoming sessions a little bit later on as well. And without any further delay, I am now going to turn it over to our speaker to get us started. So Thomas, please take it away.
All right. Thank you, Rigo. Hi, everybody. My name is Thomas Howard. I'm one of the ISE technical marketing engineers, and I'm here to talk with you about MAC Authentication Bypass. So this is going to be pretty introductory. In fact, we've actually covered a lot of these topics in previous webinars in a little bit more depth, but I wanted to put it all together because I don't think we really kind of showed you all the different ways that you can use MAC Auth Bypass to help you with your policies, because it is so essential to so many things that we do. And so to get started, I really wanted to talk about the lowly MAC address itself. So this thing is actually one of the very first things as part of Xerox PARC's implementation of Ethernet on the network. And this is the address that they chose to use to uniquely identify everything on the network. But they knew it would be more than just Xerox PARC, so they allocated these different OUIs or organizationally unique identifiers, which is the first half of the MAC address. And they left the second half of it to be variable and unique based on the individual vendors' cards that they would build for the network. And what's interesting here is you'll notice that we've got all these digits, and of course each digit is hexadecimal and it's made up of 4 bits. And together you get a full byte or an octet. There's some interesting things within this first byte. The main thing is this bit over here is what sets whether something is globally unique or whether it's locally administered. And that's interesting because of something called random MAC addressing, which we're going to get to. And then whether you do use it for unicast or multicast is the last bit of that first byte. And then if you put these things together, basically you'll find that all the OUIs that can be unicast by a particular vendor that are globally unique, that's how you get the OUIs. And so all the OUIs for all the different vendors you'll see begin with a 0, a 4, an 8, or a C. And then if you want to treat it as locally administered, that's how you can do a randomized MAC address. And that's something that a lot of our mobile devices are doing these days for privacy, is they're randomizing their MAC addresses. And those you'll see with a 2, a 6, an A, or an E. So that's something interesting. And then if you actually ever wanted to match it in a policy, this is a quick little way of doing a random match. And I'll show you an example of that a little bit later. So that's our MAC address, and if you've ever wondered about it. And it's actually gets more interesting because of the OUI, the organizational unique identifier. You get this standards list of all the different organizations that have ever applied for it. And you'll notice that some of them are private, meaning that they're not to be used. And you'll see that Xerox PARC, like I said, was the very first one. So they got all zeros. And then Cisco was pretty early in there. And they got the zeros and the C for Cisco. And then they got some other ones. I have to think that they were having some fun. I thought, let's do 001011. So that they probably got that one. And then I thought it was interesting that there's a little company you may remember called Next that had zeros with an F. And then, of course, you get other bigger electronics companies like Samsung coming in with F0. So if you ever look for those old MAC addresses, that's who you'll find. And for those of you that are too young to remember, Next is actually a precursor. Well, it wasn't to Apple, but it was one of Steve Jobs' companies that became, like, he got folded into Apple. So that's interesting. The MAC address, I think we're all familiar with it in its many different forms. So you'll notice it with what they call the IEEE 802 or IETF format with the hyphens. It can also be used just unformatted without any kind of delineation or delimiters. The thing about the delimiters is that usually for humans, it makes it a little easier for us to remember. And so you end up getting all these different variations. They call the 1-byte format, the 2-byte format. And then I think somebody decided, well, there's dots and there's colons, and then the IP addresses came along and said, well, why don't we just start using dots? And so they had to do it with dots too. And so you get all these different formats that you can use, and that kind of introduces its own fun way of doing things and normalizing our MAC addresses when we use them. But if you look in like a Catalyst switch, you can see you can actually choose what format you'd like to send the MAC address in. So interesting things with the MAC address if you didn't know those. So the way we use MAC addresses is basically to identify devices on the network at layer 2. And whenever we do any kind of authentication, we want to be able to have some kind of a factor for authenticating. And you can see there's lots of different factors these days, and everybody says, the more factors you have, the better. But I put MAB way over on the left-hand side, just barely above an open network, because really, you can't always trust who it is because it's spoofable. And so the security that it provides is kind of questionable sometimes. And so what can we do to try to make it a little bit better? And so what we do is we do try to use IPSK or MPSK to kind of involve a secret with it, some kind of a pre-shared secret that we can use to authenticate devices with MAB. Sometimes we don't have that. All we have is a MAC address. We have to figure it out. We'll try to use that OUI and maybe try to do some profiling or other things. But these are the things we have to work with when we only have a MAC address to identify an endpoint on the network. And the other thing is, everyone talks about being able to do MFA, but if you don't have a finger in a phone, you can't do it. So that's why we're really left with a lot of IoT devices that maybe they can do 802.1x, but they can't necessarily do MFA. And a lot of them, even if they could do 802.1x, they're not configured to do it. And so we're still really left with just MAC Auth bypass. And that's why it's such a big deal and why I wanted to put this together to share with you all. So if we look back at how Radius works real quick, just as a precursor to MAC Auth bypass, what's happening is when we detect an endpoint plugging into one of our network devices, the network device will issue what's called an EPOL start, which is basically saying, hey, let's talk .1x, and hopefully he'll get a response. And if so, initiate a Radius session with ICE to put the subject or the endpoint or the user in talking with the AAA server or ICE. So that's what will happen there. Of course, ideally, if it does talk 802.1x, we want to make it secure. So we'll build a tunnel to securely send the credentials over and authenticate them against some kind of a backend database, and then say, congratulations, come on in, and we'll enforce that session using VLANs, access control lists, SGTs. The user will get an IP address and they'll be on their way. That will start what we call our Radius accounting session. And that basically will increment your ICE license until some point in the future when you disconnect, you have a timeout or your authorization's changed for some reason. Maybe you're doing bad stuff on the network, so we detected it with some other security applications and changed it on you. And that's when your session may stop. And of course, that's when we decrement your license. So that's kind of the way that Radius with 802.1x normally works. But what happens when you don't respond to that EPOL start message? Well, it looks like this. So we have some subject sitting out there. We don't know what it is yet. And we try to challenge it with 802.1x and nothing happens. And so we challenge it again and nothing still happens. So we challenge it again. But meanwhile, it's maybe been ARPing out there. So we do get a MAC address from the client. And so at that point, if MAB is configured, we can go ahead and trigger MAC auth bypass over to the radius server or ISE and say, hey, what should we do with this MAC address? And based on attributes sent in the radius request packet, ISE can decide what to do with it and say, yeah, come on in, we'll take it and assign it to this VLAN, or assign this ACL, this SGT, and let it come on into the network. And we'll go figure some things out. Maybe we'll do some profiling. Maybe we'll just let it sit on a VLAN that we've reserved for it. Maybe we know it's coming in from a guest network, a wireless network, so we know what to do with it, or we're going to be applying pre-shared keys, whatever our policy says, right? And then at some point in the future, it disconnects and we can stop the session. So it's very, very similar. It really just comes down to what kind of identification information we have from the endpoint to identify it, how secure that credential material is, which if it's just a MAC address, it's spoofable, it can be randomized, all that stuff, right? And so really what we have is just what's in that radius request packet, and it looks like this. So if you haven't actually dug down into a radius request, you'll see things like the username, the password, what service type it is, and the call check is what Cisco uses for the service type for MAB. And there is actually no standard for MAB. That's one thing that was never standardized at all in any of the RFCs. Is everyone just assumed that 802.1x was going to take off and be universally implemented and everything was going to be perfect. And of course, that's not quite what happened. And so vendors like Cisco had to figure out, okay, well, what are we going to do with all these other things? And that's how we created MAB was, well, we got to do something with all these things that don't do 802.1x. And so we came up with using call check and putting the MAC address in the username and password field to represent the user, even though it may be an endpoint only. And then, of course, we can get some other information about the port type to know if it's wired or wireless. And then you'll notice things like the calling station ID, that's the MAC address of the endpoint, which matches what's in the username password field. And then the called station ID is usually the MAC address of the switch port or the access point that we're connecting to. And then we may get some other information from the network device based on how it's configured. So anyway, that kind of gives you a quick overview of how it works for wired. And in the case of wireless, it's very, very similar. The main difference being the port type is not Ethernet, it's wireless. And that in the NAS identifier or the called station ID, you may see other interesting details. I should have highlighted it, but down here you can see this is a Meraki access point, and you can see I get not only the MAC address, but I also get my SSID appended to the end. And in Catalyst and Meraki network devices or access points, you actually get the ability to customize that called station ID, and that actually can help ISE, even when you get something like a MAB request, to understand where in the network is this request coming from, what SSID are they trying to associate to, and even potentially you can include things like AP group names or tags, and that can be sent over in the called station ID. And that all these things can help ISE figure out what should we do with this particular request. So those are some things you can use in addition to the MAC address is actually what it's calling into and whatever that information is in the called station ID. So the real reason why we're doing this is because ultimately we need to control that session, control access to the network that this thing wants. And we want to know, based on whatever we can get out of it, what it is, assign it to a VLAN, assign it some kind of a layer 3, layer 4 access control list, or even a security group tag. And just remind you that this works with not only Catalyst devices, but some of the Meraki devices that support security group tags, or what they call adaptive policy. So you can use any of these options on capable devices to do enforcement, even with a low MAC address. So once we have that radius session, we can build a policy, and then based on the capability of that device, we can go ahead and use enforcement for segmentation. And that's really why we're doing radius and MAC auth bypass, is really to deal with the zero trust principle of least privilege. So real quick, I wanted to talk about some of the different solutions that we can potentially apply here. Some of you have probably used many of these things, starting with MAC filtering. That's probably the quickest, dirtiest, easiest way to do it. On the network access device, you can say, I only want this MAC address to talk to this port, and that is it. Of course, the problem is it's extraordinarily inconvenient and tedious to configure. You got to log into the network device. You got to type in that MAC address, and it's only good for that one port. It's really annoying. And that's really why MAC filtering on a AAA server like ISE is far more convenient, because you can do it in a single central place. You don't have to log into each and every individual little network device on every little switch port and configure it. You can do it all in one place. It doesn't matter where the user device goes to. They can go anywhere. It will still apply the same policy. Then you get things like profiling, which should hopefully help you to dynamically profile a device so that you don't have to manually add in all these MAC addresses in the first place. It just makes it much easier to know by that OUI or by some other networking attributes in DHCP headers and HTTP headers, whatever that network device is sending off. We can get that information and dynamically classify it based on those networking attributes. But some people, and at least for ISE licensing, they don't want to pay for the ISE licensing for profiling. And so many people do, in fact, still rely on static endpoint groups, which is a way of basically taking your many different MAC addresses, and rather than just saying any one of these MACs is fine, you can now group them and apply different policies to those different groups. And the other thing is, we have import-export capabilities with ISE from CSV files as well as REST APIs to be able to do that. And we also have endpoint custom attributes that you can update on endpoint definitions within ISE. And we even have a new option with what we call configuration management databases, or CMDB. You have the ability to integrate these external databases and use those attributes that we can get out of those to make policy decisions. And I'll show you an example of that later. So these are all the different ways that we're going to try and authenticate and authorize MAC addresses today using MAB. And just as a quick refresher, this is sort of a reference for the stuff we talked about earlier, all the different radius attributes. This isn't the complete list, but these are the frequently used ones. And I think I called out a lot of the interesting details for you already, but if anybody wants to have a kind of a quick reference of what we frequently reference, this is it. And then the other thing you'll note is typically you're going to see the MAC address represented in that single byte colon separated format, like what's shown here in the username and the password field. And that's really how ISE stores the MAC address internally, but we have the ability to look to normalize it and compare it in a lot of different ways. And I'll show you some examples of that. So if you are interested in how to configure MAC auth bypass, we have a fantastic guide that will help show you how to do this. The Secure Wired Access Prescriptive Deployment Guide goes through configuration of not only MAB, but 802.1x, talks about how to do monitoring or open mode deployment, talks about what we call low impact, or having pre-authentication access control lists to open it up a little bit beforehand before making a final decision. Or for the really secure environments, you can do restricted close mode access, which is the original intent and implementation of 802.1x, which is, you do not get access. You don't get an IP address basically until you have authenticated. And of course you need some troubleshooting for that. So all that's included in that guide. If you haven't seen it, highly recommend it. Just to kind of give you a sense, this is the global AAA configuration from that doc. And that's basically what I've used to configure my Catalyst 9300 when I'm just doing some of these demos, what I'll be doing a little bit later today. And that's for the global config to define my ISE radius server. And then for the switch port itself, I'm just using the IBNS 1.0, keeping it really, really simple. But this is, the stock policy. You can see it looks, both IBNS 1.0 and 2.0 are very, very similar with the first part. And then I put a little spacer in there between the stuff that starts to look a little bit different. We did a previous webinar. Keith Baldwin did a fantastic webinar for us on IBNS 2.0. So that's out on YouTube or in the ISE webinars archive if you want to go take a look at those and see how that works. There's just an incredible amount of things you can do with IBNS 2.0 and the different policies and filters and things out there. So go check that out if you want to know more about that. Those of you with Meraki, don't fret. We have a guide for you as well. But I will say this one is a little older. It's over 2 years old. It really needs an update. And so fortunately, it's really simple. And I've actually got some examples to show you because I happened to do a fantastic presentation at Cisco Live, which hopefully some of you were there. If not, you can still see it online. Sorry for that really tiny URL at the top, but that's how they do it. They should make it a little easier, but we'll make it available to you at the end. So this Cisco Live presentation goes through how to configure group-based policy, but it talks about 802.1x MAB and things like that. And I extracted this from that presentation, basically showing you how you can configure MAC auth bypass. If you're only interested in MAC auth bypass, you can totally do that. But what you're seeing here is I did basically the full 802.1x and MAB, or what Meraki calls hybrid authentication, where first it tries to do 802.1x, and if that doesn't work, they'll go ahead and fall back to MAC Authentication Bypass. So that's it's very, very similar to what Catalyst does as well. So these are the ways that you can trigger MAC auth bypass, and then based on your access control configuration, how you want to handle that MAC auth bypass, that can be done basically using some kind of a MAC filter or even identity PSK. So those are your different options. So what I wanted to start getting into now is the configuration of ISE, and that we have a default policy. When you go to configure your policy set, the authentication policy has this default identity store list. It's an identity store sequence or different stores that you can choose. And the default is all user ID stores. And this is fantastic if you're authenticating users that have usernames and real passwords. But what you'll notice is if you're going to be doing endpoints with MAB and ISE, those are all stored in the ISE internal endpoints database. And unfortunately, that's not even selected. And so if you start to do 802.x or MAB, if you do MAB with ISE, by default, everything's just going to fail because it's never going to find what's called effectively the username or the MAC address in that radius request. It's never going to find it because it's not looking in that database. So you need to change that. So make sure you change it to internal endpoints if you're doing MAC auth bypass, if that's one of your options. And then the next thing is if the user is not found by default, it will reject it. That's a really nice, secure default option, right? Well, unfortunately, when you're plugging in IoT devices or other devices that use MAB for the very first time, how annoying would it be if you're a guest user that is trying to use MAB or something on a network and it immediately rejects you, right? That's not very friendly. And the reason why is because until that MAC address has actually been populated in the ISE endpoint database, the user or the MAC address in that username field is considered not found. And so you're going to get an access rejection the first time. It's really, really annoying. So you want to change that one too if you want to be a little more friendly. And instead, I recommend using the continue option if the user is not found. And basically what that does is that says, you know what, just hold off on your judgment and let's go through the authorization policies down below and let's figure out what we should do with this MAC address based on the policy. So that's the changes you're going to want to make when you do MAB and ISE. Otherwise, you'll be quite frustrated by default. The other thing is just note some of these options. like I said, reject is very unfriendly, and it just doesn't access reject immediately. And so drop would actually just drop the packets on the floor and would not even respond back to the network device. So that's even more unfriendly, if you can imagine that. But then continue, like I said, it'll just let you keep going. So just be aware of that detail. And then the policies that I've configured look like this today. I went ahead and I was very explicit. We do have conditions to kind of help simplify this in ISE, but I wanted to spell out so you could see the exact attributes that we're using to match a wired network with the Ethernet type and the frame type for .1x, or the call check for MAB requests, right? And login for WebAuth, things like that. I wanted you to be able to see all those. That's why I did it this way. And so for that, I wanted to go check out some ISE default authentication. So let's see how we're doing today. We're doing all live today. We'll see how we do with this. So real quick, there's that same policy I was just showing you. We're going to do a default authentication, and I went ahead. I'm just going to show you my wired MAB policy real quick. So when we come in here, we look at the authentication policy. I'm going to change this from internal endpoints. I'm going to go back to that all user ID stores. And I think I already changed it. Yeah, we're back to default with reject. Okay. So let's go see what happens if we first save the policy. That would be good, right? Let's save the policy. And then we're going to pull up our trusty heap test client. I didn't want to sit here and be plugging endpoints in and out constantly. And especially with some of these that are PoE devices, I didn't want to have you sit and wait a minute for them to boot up. That would just be really boring. So I'm going to do it the quick and dirty way with my EAP test client. We've used this on many webinars before. If you guys aren't aware of it, I'm sure somebody will post a link to it in the chat for you all. So basically, I've got some things pre-configured here. And sorry, this is a little small. I wish I could make it the text a little larger, but I can't do it with this client. So this is a Mac OS only client that we're going to test with this ISE server. And basically what happens is you'll notice we've got a MAC address. I just put 112233445566, or this one's 99. There's 66. And you can see the calling station ID that matches the MAC address, and the MAC address is also in the username and password field. And so the only other thing to note is we've got the service type of call check. That means it's going to be a MAB request coming from the network device. And we also have the port type as Ethernet, which means it's going to be a wired MAB request. So now if I go ahead and I start this, you see I immediately get a reject. And if I come over here, not the last 60 minutes, let's do the last 5 minutes maybe. You can see our endpoint came in and hit the default access and was failed. So if we go back, and no matter how many times I do this, it's just going to keep failing no matter what I do. And you can see all those different times I did it, it's going to fail every time. So we need to go back and we need to change that policy. So if we go into our authentication policy, first thing is let's make sure we check internal endpoints. And then the next thing is if the user is not found, let's make sure that we just continue. Let's do the nice thing. Actually, no, let's keep it as reject for right now. Let's see what happens if Thomas was right when he said that the first one's going to fail and the next one is going to work. All right. So internal endpoints, and we're going to reject it if it's not found. So if we go back here and we go back to our EAP test client, the first one should fail. So let's do it. Oh, I was wrong. Probably maybe somewhere along there, it did put it in the database. But once it is in there, it will work. So that is the good news, is that it did actually work. And you can see that it matched some policy, single MAC by colons. We'll get into that one. So it worked, great news. And that's how you set up your MAB. Well, actually, let's go change our policy real quick. Let's make sure that we're on continue. And what I want to do is save this policy. And just to show you now that we've got that set up, I should be able to bring up another MAC address. Let's do this one. I should be able to run that, and it's going to get accepted. That first one didn't get dropped. So this one, you said, okay, we're just going to trust it. We're going to go through, we're going to check out the authorization policy. And when we do that, it worked. It's the 991 on this one. And that we matched with a, looks like an OUI wildcard. So we'll take a look at those here in a bit. So that's the default authentication. The next thing I wanted to show you is how we're going to be able to do some local and global exceptions. So the thing to note about ISE authorization policies, or authorization policies in our policy set, is that it works top down. And so if you think about how we're doing this, we're going to authenticate first, and then we're going to try and look in our local exceptions for any matches. Then we're going to look at our global exceptions, and this, whatever you put in the global exceptions applies to all of your policy sets. And then finally, you have the specific authorization rules in this particular policy set. That's how this works. So I wanted to kind of show you how that works. And I wanted to do it in this context here, where we also talk about MAC filtering. So this is kind of a quick representation. I'm going to show you what this looks like in ISE itself. But these are ways that we can match on the MAC addresses. So earlier, I talked about that calling station ID in Radius, and there is a special operator for MAC addresses. There's a bunch of different MAC operators actually to match on MAC addresses and basically normalize these things so we don't have to care about whether it's dashes, colon, dots, or question marks, or who knows what kind of crazy delimiter between these bytes in the MAC address. So we can do a single match if you wanted. We can do multi-match, or we can do basically an OUI match with the MAC starts. So with that, let's go take a look and do some MAC filtering. All right. Now, sorry, I've got my access point over here. I should probably unplug it because it's kind of really annoying to keep trying to come in. What I want to do is let's go take a look now. So if I look at my policy sets, again, wired MAB, I want to go take a look. You've already seen the authentication policy, right? It's all set to allow or just continue with the endpoints. I did a few local policy exceptions. And what I'm doing here is I have one. This is going to be with a custom endpoint attribute. We'll talk about that in a bit. I have one that's an exception, and I have an unblock one that basically will override the block one down here. So remember what I said is that it works top down. And so if you had something like a blocked policy, so in this case, we can have an identity group that's a static endpoint group that we can just put MAC addresses into, and we're going to consider them to be blocked. So anything that goes in this static endpoint group will be blocked. So we're going to do a match on it, and then we're going to block it. So what I'm going to do is let's test that theory out. And if I go to my eat test client, I've got my blocked client. I tried to emulate basically block with hex digits over here. So let's see what happens. Yes, I'm blocked. And no matter what I do, I am blocked because that MAC address is sitting in the blocked static endpoint group. And let's show you what that looks like. So if I go over here to identities, actually groups, you can see I have a bunch of different groups defined, like blocked. Maybe you have one that's allowed. Maybe you do it for cameras or IP phones or Meraki devices, or maybe people always like having an exception group that, you know what, this person is having trouble getting in. We've talked to them on the phone. We just need to get them some access so they can get their machine updated or something. Let's go throw them in the exception list or something. Or maybe you have different groups for facilities. The guest endpoints is actually the one that ISE uses internally for placing MAC addresses into what we call the guest flow. So there's all these different endpoint identity groups that can get used. You can define your own, like I did one for Pixie Boot or Quarantine or my Raspberry Pis or whatever. So we have all these different options. And if I go take a look at my blocked list, I should have just shown you this. It should have been in there. I guess I deleted it. Well, let's go add it in there. Where's block? All you have to do if you want to update that static group is just like that, and it should be added in immediately, and it should continue to be blocked. Now it makes me wonder why it didn't work. This is the joy of live demos, right? I must have another policy preventing it from coming in. So it matched on the block policy. Oh, it was going to default. Okay. That's why it wasn't, but it did finally start. Once I put it in the static group, it matched on block, and that's what we want. So that's good. Then I wanted to show you how we can basically override that with our policy. So if we go to the policy sets again and wired MAB, what we can do is, oops, don't need to go there yet. Our global exception is to block it. Maybe, and again, that gets applied to all the different policies. So if we go into other policies, you'll see they all have the same blocked policy because we want to globally drop anybody coming in with that MAC address or MAC addresses in that group. We can actually say, you know what, but we do want them to come into this one. We're going to enable the unblock policy. And now people that are coming into the block policy are going to be allowed to come in on this. So let's go ahead and save that. And if I come over and I run my test again, hopefully, yes, the local policy overrode the local exception overrode the global exception before it ever even hit the authorization rules in that policy set, and it worked. So that's cool. There's your global exceptions and local exceptions. So MAC filtering. I forgot to show you some more MAC filtering. Let's get back to that. So local, global, and now let's do some filtering. So if I look up here, I can do all kinds of different matches. So I did one for randomized MAC addresses. Remember I showed you that earlier, how we can match on that second digit and permit access. So I can go ahead and do that real quick. I've got my, where did I put my random? Oh, my random is, it's the E, the exception. So I did an exceptional one. Let's see what happens in here, because E is one of the characters. It worked. And if I go look at my policy, E worked, and it was matching the random MAC policy because it has an E in that second digit. Next one is if you wanted to create an individual exception per MAC address, you could do that using the calling station ID. And I mentioned that it can match by, you can match by anything, but the thing you have to watch out for if you use the equals is this going to look for quite literal matches here with the colons and the dashes. And that's why you see this unformatted option here where we're using the MAC equals. And you'll see, I don't really even care about what the delimiter is. It should just work. So what I want to do is I want to go ahead and try to do some hits real quick. First, let's try with colons. So if I go and I do my colons with the 66, let's see what happens there. That got accepted, and that should match the colons, single MAC by colons, right? That worked. But the next one is maybe I want to try it with some dashes. So let's go try, where's my 66 with dashes? Is it this one? No, that's 99. Where did I put it? Oh man, I got too many MAC addresses. Let's try this one, see if this one works for us. It was accepted. 99 came in. Oh, it hit the wild card because I wasn't matching right. I have another one in here. Let me just, since we're here, let's just show you 77, 66, 77. Let's try this one too. That one matched. And 99, I think we did him already. Let's try him again. What we can do is, yeah, so we have the multiple max matching with the 77, and we have the MAC OUI matching with 99. Let's go take a look in our policy. So 77 matched here, and 88 wasn't there, but we could have hit it if we had it defined. The 99, it bypassed all of these, and it matched on the OUI. But what's interesting is in my policy, when I defined it for the EAT test, it was using the colons as the separator for that MAC address. But that's okay, because when we use the MAC starts, it parses out all that stuff and only looks at the first few digits, starting with that basically the OUI. So we're able to go ahead and apply policy to these things and not have to worry about whether we get the colons right, or if it goes in on one network device and it sends colon separated MAC address, and a different network device sends hyphen separated MAC addresses, or maybe no separators. It doesn't matter. So the key here is to make sure you use the equals, or I should say the MAC operations. So let me show you what that looks like if we go into our conditions. So radius calling station ID, because we know that's going to be the MAC address, should be the MAC address of the endpoint coming in. You'll notice instead of just the normal matches contain starts with ends with rules, we've got all these other rules for matching MAC addresses specifically. So if you want to try and do MAC matches, go ahead and use these. This is probably the way to do it. Just be careful with this, because one thing you probably don't want to do is create a whole bunch of authorization rule entries for, line by line, MAC by MAC, right? That just makes for an extremely inefficient policy set. Much, much better to use identity groups like what we've got down here. So let me go try and show you some of those. Let's go back to our presentation. So we showed you some MAC filtering. So we got our static endpoint groups next. So what we want to do is let's go ahead and talk about those. I kind of showed you a preview of this already. So probably no reason, don't need to dwell on it too much. Let's just get right back into the demo. So static endpoint groups, I showed you that we have some for cameras, facilities, signage. You saw blocked, you saw guest endpoints, you saw lots of different ones over there. So what I've done is, let's go take cameras, facilities, signage. Let's go take a look. Let's just go like this. We got groups, and I said cameras. We got a Meraki camera sitting in there. Facilities is another one. Don't have one there. I should have. I think what happened is I erased it when I was trying to clear it out in preparation. One of these is facilities, and I forget which one is it. I guess I shouldn't have deleted the endpoints. So this is actually a really good lesson to you all. When you start purging your database, it will purge them from the endpoint identity groups as well. So you need to be careful when you do your purges so that doesn't happen. Otherwise, you might lose your associations, and that kind of creates a lot of work for yourself. So let's go ahead and try and run some of these. Let's go back to, let's go here, and let's just try running some of these different things that I have. So I've got these are my Raspberry Pis that should have been in some of those groups. I'm going to go ahead and run these two. These are wired MAB requests, and you can see it went ahead and it matched it based on profile, because I have profiling enabled at the top. I'm going to go ahead and plug in my real Raspberry Pis, and we'll see what happens. All right, got those plugged in now. So basically what happened is it was able to identify the Raspberry Pis based on their profile, because this profiling rule has the Raspberry Pi MAC address inside of it. And that's how we're able to know the OUI for that particular vendor and note that it's a Raspberry Pi. Now, in my policy, if I wanted to override it, let's go take a look at what I have written for wired MAB. If I were to put those into these groups, and it wasn't doing the profiling way up here at the top, if I were to disable this, it would have fallen through. That's probably what I should have done. I forgot to disable that policy. It fell through, and it would have fallen through and matched on these. So in this case, I'm going to go ahead and turn that off, save it. So hopefully if I authenticate again, let's see if that works this time. If I go and I redo that authentication, it should fall through. Oh, it got blocked. Oh, because it's not in the group. Okay, well, see, policies are working right. So if I want to add one of those, I need to go ahead and put it in the right group. So let's go add A3BA. Let's go add it to, let's put it in facilities. Let's add A3BA, this one. It's added now. And now if we go back and we run it again, it matches now because it matched the group. And if we go look at our authorization, it matched the facilities group, right? So you can see how you can play with this. Lots of different options on how you might want to do this. And including the ability to use profiling. So let's go back to our presentation real quick and let's see about profiling. So the idea here is hopefully you can see, Thomas screwing up with his different endpoint identity groups and how, you can make mistakes with it, and you can, it takes some maintenance to know which group does this thing belong to and who put it in this group and all that kind of stuff. The whole idea of endpoint profiling is to make it easier for you and more dynamic by using attributes, network attributes of these endpoints that we discover when these endpoints are on the network. So we have these different probes that we can use. We pull out different attributes from these networking protocols and then use them to match a policy. And that's what we did for the Raspberry Pis that I was just showing you. So if I go back and I try to look at, you can see I've got an endpoint profile for Raspberry Pis that I'm matching. Now, this isn't necessarily going to take me to the policy for it. I think it's just going to show our inventory of Raspberry Pis. So what instead I want to do is I want to go over to administration, work centers, profiling policies. And I want to take a look. If I try to filter, let's look for Raspberry. There's the Raspberry Pi device policy. And inside of here, we can create a policy that will allow us to match on Raspberry Pis without having to move it back and forth between these static groups. It does it dynamically. Basically, there's a rule that it's going to check for. And as long as it contains one of the MAC OUIs for Raspberry Pis, it's going to do that automatically for us. So we don't have to do that MAC OUI rule. So that's a real simple example. Other things, like, when we try to match iPhones and Mac OS and Windows workstations, there's a lot more of these profiling policies and rules that are in there. But for something simple like a Raspberry Pi, this is how quickly and easy it is to do it. So that's how you can use profiling. And I think we actually need to have a profiling webinar coming up that kind of goes through all these options. So I'm not going to cover it today, but that's really what we need to cover, I think, in an upcoming webinar to help you understand how this works and how you can build more complex profiling policies dynamically so you don't have to do all the static endpoint group stuff. So with that, the next thing is endpoint custom attributes. So hopefully you've seen that profiling gives you the ability to dynamically discover based on networking attributes, but some things you just can't get from the network. Like, what organization does this thing belong to? Who's the owner of this device? Is it operational, or is it in maintenance mode, or in service, or it hasn't been expired based on some other policy, right? You just don't get that. And so usually these are things decided by people and organizations and inventory asset workflows and things like that. So we actually have the ability to do some endpoint custom attributes in ISE. So you can actually go in and create these different attributes with data types and then create policies based on them. And so let's take a look at how that works. So back in ISE, let's go back to our policy. And again, wired MAB. What did I want to match? We got the groups. Oh, I know what it was. I had an endpoint. I probably deleted it. Oh, I know what it was. That's where the global exception came in. So for global, we had a blocked, and for local exceptions, we could have an endpoint that was in an exceptional group. But the other one that you'll notice I have up here is a maintenance. So if a device is flagged with an endpoint group attribute called status being in maintenance mode, we should deny it because it shouldn't be on the network. It's supposed to be out being serviced somewhere. Nobody should be allowing that thing on the network. So let me update that, and let me go see who's in maintenance mode, or who can we put into maintenance mode. So the way to update these is you could use REST APIs. The other way to do it is through what's called context visibility. So if I take one of these MAC addresses, let's take 99 here. Let's take him. And if we go look at his attributes, we can see our custom attributes. There's lots of other attributes we know about 99 over here. But here we have, these are some attributes that I created earlier, so you didn't have to watch me type them in. And for status, I want to change it to be maintenance mode. And so for that, I need to come up here and click on edit and look at my custom attributes and status. I'll edit that field and I will say, this guy is in maintenance mode. He shouldn't be on the network right now. So I'll save that. And now if I go back and I try to authenticate, where's my 99? There he is. He gets rejected, right? And if I go back into ISE and I take a look at my live logs, hopefully we should see, you're in maintenance mode, dude. Sorry, you get denied, right? So that's how we can use local attributes. And again, it could be for anything you wanted. It could be organizational, departmental, financial. It could be used as those temporary exceptions as well. That's why I tried to show you some examples over here by showing not only maintenance mode, but an exception. Like I said, if somebody has an exceptional situation, they just need to get network access, we're just going to give it to them. We'll put them in this group and it'll just work. That's a way you can use these exceptions to do that, use these groups for that. Or maybe you want to use, instead of using a whole group, maybe you just do it by endpoint as a local attribute. So there's that. And then next thing is CMDBs, configuration management databases. So you could imagine if you're trying to update these attributes in ISE, like you're the ISE administrator. You don't want to be doing all this in ISE. Like this should be somebody else's job, some other workflow somewhere doing this. And that's really where CMDBs come in. Configuration management databases manage these assets through basically an inventory lifecycle, and they track all these crazy different things about them. And they get put into a big database. And ideally, we can extract this stuff using cool things like JSON and REST APIs. And you can see we have these different attributes we can use because we're network people. We use a MAC address for a primary key. We want to see, is this thing current? What group does it belong to? Is it operational? Is it in maintenance? What's going on there? Or maybe it tells us exactly how we should authorize this thing on the network if we do see it. So all these cool things we can see, and we can do it using PX Grid Direct. This is a new feature we added in 3.2, ISE 3.2 patch 2 and ISE 3.3 to do some really cool things. And I'll try and show you those really quick. So what we do is we can connect to these different external databases using a REST query, pull the JSON data like I was showing you. Like I said, I did a whole webinar on this earlier, so you can go dive into the depths. You've probably already seen it if you're a frequent watcher of all the webinars. But for those that haven't, I wanted to give you just a really quick idea of how that works. So when we pull that data in from the database, you saw basically all those values. The way it works is we look at our policy. In this case, I'm going to be using it for IPSK. You saw that I have an IPSK CMDB. So for my wireless MAB IoT devices, I created some policies, and it looks like this. So whenever I see something coming in, I'm going to just, I had to restart my Raspberry Pis because they're the ones that are going to be doing this wireless authentication. So what happens is I can match on a dictionary for that IPSK database. So when I import it, it becomes a data dictionary. I can choose IPSK, and then I can choose any one of those attributes to match on and a value for it. So that's pretty cool. And that's exactly what I'm doing here. I'm choosing the department and the status, and I can do any other fields and match against those and use those policies. The other thing I can do is not just match those attributes for the authorization rules, but I can match it for the radius authorization profile response, and I can put that in there as well. So hopefully my Raspberry Pis are going to boot here really quick, and I can kind of show you the result of that. But basically, well, here it is. It happened a little bit earlier. You can see where my Raspberry Pis came in, it matched on wireless, and then it implemented the CMDB IPSK authorization profile. So what that did is it actually went in. Let me just show you that. Policy results. Authorization profiles. CMDB IPSK. So what we're going to do is we're actually going to return, again, there's that IPSK database in the IPSK field. We're actually going to send the IPSK attribute that's in that database, that external database, back to, in this case, this is the Meraki access point, and this would be a Catalyst wireless controller. It'll send that value back, and it'll be used for IPSK association. And if it matches with the endpoint, great. If not, sorry, you don't get access. But the idea here is, again, the ISE administrator doesn't have to maintain all this. It's already done by some other workflow and some other centralized managed database. And we just take advantage of that and use it in our policies. So that was hopefully a quick tour of a lot of different ways that you can use MAC Auth Bypass with ISE. And so here's all of our resources. And I don't know if we have any questions, Rigo, real quick.
Yeah, thank you, Thomas. We actually just have one outstanding question from our audience. Okay. And that question is, what is the best method to define the policy set? .1x and MAB or wired and wireless and have 802.1x and MAB policies in each policy set?
Oh, great question. It really depends. There's no right answer. It totally depends on your scenarios, how your organization works, how your devices are lumped together. Are they wired or wireless? Like I tried to show you some examples. Let me just get back there really quick. If we look here in my policies, if your organization has implemented 802.1x, and that is the most frequent thing that people do. Maybe you have a lot of wireless users, and so maybe you probably need to add a wireless 802.1x up here. So that would be one thing. Is what's the scenario? And remember, this is basically an access control list, and so whatever the scenario is that's most frequent, that's probably the one you want to put on the top. And you also need to be aware of having too many of those global and local exceptions because those get processed before anything else. And so really it's almost a performance question of what's the most frequent thing you do. And for that, I recommend you look over here at the hit counts and you can see that it looks like we actually have had a lot of hits on .1x. And so putting it at the top was the right answer. And then putting this one next was the right answer. And this was the right next answer. And this one, and then we get a few people falling through the default. And that's okay if we put them if we deny them because they fall through for some reason. We got to go figure out why they're not working. But otherwise, think top to bottom in terms of most frequent to least frequent. Also think in terms of the specificity of these rules. What you don't want to do is go check 27 different things before you actually hit a match and then go evaluate it. And then you get to the 26th one, like, oh, no, not quite a match. I'm going to go to this one now. You need to be fast. And so try to use really quick things here. So we're checking on wired versus wireless is what you see here. And is it .1x framed or is it MAB call check, right? Really quick, easy matches. And we save, if you even look down here, you'll notice the radius called station ID matches on a string. The string is the last thing because that is the most CPU intensive to do a string match rather than just checking a single numeric byte on these. So we check for the bytes and then finally we go for the string. And hopefully that works faster as well. So it really depends on your organization. Do you have certain scenarios or classes of devices that are wired, like maybe it has some wired IoT. Maybe I have an organization that's kind of split. We've got like universities and they have hospitals or health centers attached. And so maybe they have two very separate kinds of things. And so maybe you separate them by the network devices for those kinds of things. You can actually put network device rules in here to separate those out very quickly. So it just depends on what your scenario is. I know it's a long answer, Rigo, but it's a huge topic. In fact, Charlie Morton did one on policy sets. If you go check our webinar archives, he did a great one talking about effective ISE policy sets, but trying to give you some background on that.
Yeah, no worries, Thomas. That was a perfect answer. Thank you so much. And actually that does it for our questions from our attendees. I think we're all set there.
All right. Thank you.
All right. So, Thomas, I just want to thank you for speaking about this topic with our audience. I hope that everyone found great value in the information and resources that were shared here today. I would also like to extend a very big thank you to each and every one of our panelists for lending a hand with the questions throughout the webinar. We really appreciate it. And for our attendees, if you do have any additional questions or would like to continue the conversation about today's topic, we do encourage you to participate in our online post-webinar discussion. You are going to be redirected there upon exit, but the link is going to be posted into the chat window here in just a moment for your reference. So we look forward to your participation.